Hi ladies, in this video we're going to go through questions 6 to 11, which are a little bit harder questions than the previous 5, just because they're problem solving, but also they're worded problems and you don't have any diagrams. So hopefully this video will help you guide you through those questions by drawing the diagrams. And I apologize with the extremely windy weather outside. If you can hear the howling, I'll do my best to talk up a bit so you can hear. Okay, so question 6. A 100-meter radio mast is supported by 6 cables in 2 sets of 3 cables. All 6 cables are anchored to the ground at equal distance from the mast. The top set of 3 cables is attached at a point 20 meters below the top of the mast. Each of the 3 lower cables is 60 meters long and attached at a height of 30 meters above the ground. If all the cables have to be replaced, find the total length of cable required. Give your answer correct to 2 decimal places. Wow, what an exhausting question. Okay, so we're going to have to draw a diagram. So I'm going to make this a bit smaller so I can read and draw the diagram at the same time. All right, so we've got a 100-meter radio mast. So let's draw that first. So do that. So that's 100. And you know how I like colour, so let's draw the cables in a different colour. Draw them in green. So it's supported by 6 cables in 2 sets of 3. All 6 cables are anchored to the ground at equal distance from the mast. Okay. The top set of 3 cables is attached to a point 20 meters below the top. Okay, so go to here. So 20 meters below the top. So we've got 3 green ones. And this is kind of drawing it in 3D. So I apologize that my diagram is not the best. Let's maybe make that a little bit shorter. Oh, I got rid of it altogether. Okay, so you've got to kind of picture what this would be like in 3 dimensions. Probably haven't done it justice, but pink is vertical and then our cables going off it. Okay, each of the 3 lower cables is 60 meters long and is attached at a height 30 meters above the ground. Okay, so we've got 3 more. So they're kind of attached at the same point. That's how I'm seeing it anyway. If all the cables have to be replaced, blah, blah, blah. Let's just get our distances in first. So we've got our 100-meter post. We've got 6 cables are anchored to the ground at equal distance from the mast. Okay, so equal distance from the mast just means on the plane, on the horizontal. The top set of 3 cables, so that is our green, is attached to a point 20 meters below the top. So this is at 20 here. And that means the height is going to be 80, but I'll do that later. Actually, I'll do that now. So let's do a green cable. So I'll draw that in green. So I know the vertical distance is 80 because it was 20 meters from the top. And let's do the blue ones. Okay, so the top set, 20 meters. Each of the 3 lower cables is 60 meters long. Okay, so if I draw that over here, so that's going to be 60, the diagonal, and attached at a height 30 meters above the ground. So that's going to be 30. If all the cables have to be replaced, find the total length. Okay, so I'm going to have to use this blue triangle first because this distance here, which I will call, let's call it A, is the same as this distance here. Okay, because says in our question that they are anchored to the ground at an equal distance from the mast. Okay, so they're all attached at the same point. So they're all the same distance. If you can think of the horizontal on the ground. My diagram is not the best, but let's keep going. So what color should I do? Purple. All right, so we're going to stick with the blue triangle first. So let's write Pythagoras' theorem. So a squared plus b squared equals c squared. Substituting what we know. So I labeled the unknown side a, but you could use any letter. 30 squared equals 60 squared. So a is equal to the square root. So remember, to get rid of the squared, I'm taking the square. Oh, actually, I skipped a step. Sorry. Let me just rub that out. Okay, so let's subtract, first of all, 30 squared from both sides. Now, you could skip this step, which is what I was about to do, but I don't want to confuse you. Okay, so 60 squared minus 30 squared. And then we take the square root of both sides. Now, I want to do that in green. Okay. So the reason for taking the square root, remember, is to get rid of the squared sign. So a is equal to the square root of 60 squared minus 30 squared. Now, I'm going to get my calculator up. Obviously, you don't have the same, or maybe you have the same calculator as me, but you can see it here. I'll just move it over so you can see my buttons. So the square root of 60 squared minus 30 squared. Now we press enter. So we've got 51.96. So that means this distance down here is 51.96. Now we want to do the total length of cable. So we already know the blue cables are 60. So we've got to find this distance here, and I'm going to call that C. So again, I'm going to use Pythagoras' theorem. So a squared plus b squared equals c squared. Now, it's probably not best to work from right to left on your page, but because I'm kind of doing this as we go, I need to do that. Now, your value of A, remember, we've got 51.96, so I'm going to rewrite that here, but usually we would keep it in its exact form. Why am I writing equals again? I'm so used to Pythagoras putting the equals there. All right, plus 80 squared equals c squared. And then to get c by itself, we take the square root of both sides. And I prefer my pronumeral on the left-hand side, so I'm going to do c equals. And then we just put this into our calculator. So what I did before is I had this value here, so I can just press enter and square it if you like. So 2,700. Let me just go back. So 2,700 plus 80 squared. Ooh, where am I? Where's my calculator? So we want the square root (2,700) plus 80 squared, and I get 95.39. Now your total cable. Now we've got 6 cables altogether. So we've got the green one. So we're going to do 3 times 95.39 because we've got 3 green. And then we've got 3 blue. So 3 times, and we already knew they were 60. So go back to the calculator. All right, so this length I'll just do times 3 plus 3 times 60. Wow, so windy outside. And 466.18. And what are we working in meters? Okay, so quite a long question and probably not ideal to work from left to right. But I always, when I draw diagrams, like to give myself a lot of space. So that's what I've done there. All right, let's go to the next question. All right, question 7. In a particular circle of radius 2 centimeters, AB is a diameter and C is a point on the circumference. Angle ACB is a right angle. So ACB. So that just means we're forming a triangle, or we're drawing a line from A to C and then a line from A to B. So if I go down here, oh, sorry, no. Wrong way. I go down this way. Oh gosh, that's supposed to be a straight line. That's a right angle in there. This is why we always have to redraw our diagrams. Angle ACB, so we're going from A to C down to B. The chord AC, so the line AC is 1 centimeter in length. Draw the triangle ABC as described. So I'm going to draw it the same way it is on there. So we've got A to C is 1. And then we go down much straighter line. Okay, that's a bit better. That's a right angle. And that's not 2, that's B. All right, so 2 is halfway, our radius. All right, find the length of BC correct to 1 decimal place. Okay, so what we need to do, we've got to figure out, well, what information do I have? So I know that our radius is 2, but that's half this distance because A to B is your diameter. So if this is 2, this is also going to be 2. So the whole distance here is 4. All right, so to answer question B, I'm just going to quickly redraw the triangle just because I like different colors. Now, you can redraw it around the right way if you like. Whoops. I'm going to just quickly draw it here. So 1, 4, and my hypotenuse is here, C. So I'm going to call this other side, the shorter side, A. So I'm going to write Pythagoras' theorem, substitute in what we have. So A squared plus 1 squared equals 4 squared. And then just solve for A. So we're going to subtract. 1 squared is just 1. This is something that we don't really need a calculator for. So we subtract 1 from both sides. So that goes. Oh my gosh, this weird. I feel like things are going to come crashing down in my house. 4 squared is 16. So 16 minus 1 is 15. And then to get A by itself, we take the square root of both sides. So there you go, there's a third, but it does want us to put it to 1 decimal place, so we'll do that in the calculator. God, this question isn't as confusing as the previous one, which is nice. So the square root of 15, we'll just do in the calculator. So square root of 15. And to 1 decimal place, so we're going to have to round up, so 3.9. And I think we're working in centimetres, is that right? Yes, 3.9 centimetres. And when we look at our question, we know it has to be less than the hypotenuse. So 3.9 is very close. So the angle here must be quite small. All right, let's move on to question 8. A suspension bridge is built with 2 vertical pylons. So they're labelled. Nice. We've got a diagram for this one. And 2 straight beams of equal length. 2 straight beams that are positioned to extend from the top of the pylons to meet at the point C. Okay, so this is 65, I assume. And this must also be 65 if they're the same distance. Calculate the vertical height of the point C above the tops of the pylons. So I might just use a different colour. So we want the vertical height. So we want this height here. Whoops. Okay, so let's just redraw the triangle. It's a right angle, so I'll put my right angle in. This is 65. What other information do we have? Oh, well, this is easy. We don't have to use Pythagoras just yet because this is 25 and here we've got 72. So for question A, it's just 72 minus 25, which is what, 67? No, 47, sorry. It's really hard to concentrate with that wind. I'm going to blame the wind. 47 meters. All right, so on my triangle now, I can put in 47. Calculate the distance between the pylons, that is the length of the span of the bridge. So we're going to find this distance down the bottom. I'm going to call that A. So let's write down Pythagoras' theorem and substitute in what we know. So let's just change the colour for the fun of it. All right, so we're solving for A. So let's subtract 47 from both sides, 47 squared, sorry. And notice how I don't actually do 47 squared. I don't want to deal with like big numbers. So we'll just deal with them at the end. So 65 squared minus 47 squared. Now to get rid of that squared sign, I take the square root of both sides. So A is equal to the square root of 65 minus 65 squared minus 45 squared. So we'll do that on the calculator. All right, so to one decimal place, it's going to be 44.9. Now, I love it how the pitch of my voice says we're not over yet. So we just found half. We want to find the full length, okay? So we have to just multiply that by 2. So the full length equals 2 times A, 2 times 44.9. So let's just go back to the calculator. Now, I don't want to type that again. I'll just do times 2. And 89.8. And we're dealing with meters. I'm just going to quickly check the answer. 89.8. And I didn't check the previous question. Cool. I should check the questions as I go, because if I make an error, I have to go back and edit the whole video, which is very annoying. All right, I can't believe the first question took me 10 minutes and I'm flying through these other ones. All right, question 9. 2 circles of radii 10 centimeters and 15 centimeters respectively. So radii, just plural for radius, because you don't want to be saying radius. So 10 centimeters and 15. So obviously the smaller circle is going to have 10. So you can see that there is 10. And the bigger one is going to be 15. And remember, radius is just from the center of the circle to the outside. So we've got these other dotted lines. They're also 15 centimeters long. Find the perimeter of the square to the nearest centimeter. Okay, so we want to find the perimeter, and I might do this, highlight this in yellow, because why not? So we want to find this whole distance. Now I can think of, all right, I'm just reading the hint because I'm thinking about how I would do it. There's probably several ways you could answer this question. First, find the diagonal length of the square using the diagram. Okay, so we know this is, okay. Now, that's not, all right. So if I kept going, we're not going to find the full diagonal. So I'm just wanting to know, okay. Now I'm thinking aloud. I might have to pause so I can keep thinking. Okay. this distance here is not your radius because we're going straight from there to here. So I made a mistake before when I said the 3 other dotted lines are also 15, but I didn't actually note that the dotted line kept going to this corner. So we've got to find this length of this purple line. So what I've got is a right angle triangle. So if I go down here, and you'll notice I'm doing it in orange, there's your right angle triangle. These two orange sides, so this side here is the same as this base, of 15 and 15. So if I just redraw that triangle here, we're looking for this purple side. So if you can kind of see it on the diagram, I'll just put my right angle in. These two sides are 15. Oh, this is a tricky question. All right, and this is your hypotenuse. So let's write down Pythagoras' theorem. All right, your value of A and B, they're both 15. And then we've got C squared. So C is equal to the square root of 15 squared plus 15 squared. And I don't think we're going to get a whole number. So let's just see what we get. So 2, 1, 2, 1. Okay, so we found this distance. Now we've got to find, and I probably shouldn't have put that orange top bit there, so I'm going to rub that out. Because it was from the outside of the circle, but you can see that other dotted line goes to the corner. So let's do that in a different color. I'll do that in green. Oh, which isn't ideal, is it? God, I hope no one struggles to see in color. So those 3 lines are all 10. And we want to find this distance here. So it's kind of like the same as before. We've got our 2 sides, which are the same. They're both 10. And then we have, why didn't I draw that correctly? Sorry. I'm just going to redraw that to fit the diagram. Okay, so 10 and 10, and then the pink on this side. Okay, so we're doing this triangle in the corner here. So this is C. So writing down Pythagoras' theorem. So 10 squared plus 10 squared equals C squared. So C is the square root of 10 squared plus 10 squared. So you can do that on your calculator. Now you're probably sitting there and thinking, I know that's the square root of 200, but I'm just going to always write things because sometimes people are watching and they might think, oh, where did you get that value from? Okay, so we've got 14.14. All right, so now I can do my bigger diagram. And I'm just trying to think, what can I do that in? Let's have a look. We'll do light blue. So this, oh, it's like a little colored disco. We're doing that right angle triangle now. So our diagonal, we can work out from before. All right, so I just drew the triangle. Now our diagonal, when you think about it, is 15 and 10. Okay, so I've added the 2 radii together, and then the 21.21 and the 14.14. So this diagonal are all those values calculated together. And then the other 2 sides I've just called x and x. So when we're using Pythagoras, a squared plus b squared equals c squared. So the a and the b I've called x squared and x squared equals c squared, which is all of this. So I'm going to put that into the calculator. All right, so we've got this value plus this value plus 10 plus 15. So 60.355 And we've got 2x squared, so we'll do 2x squared equals 60.355 squared. I'm going to just leave it as squared for now. So solving for x, divide both sides by 2. So we've got x squared is equal to 60.355 squared over 2. And we want to get x by itself, so let's take the square root of both sides. And it's looking very, very tricky, this question. Okay, so I'm going to put all that into my calculator. So I'm going to, first of all, square what I had, divide by 2, and then we're taking the square root of that. So everything that was written there I'm just doing it in separate steps. So 42.68. Oops, why am I writing it? Now, that is just the length of one side. I think the question wanted us to do the perimeter. Find the perimeter. So we're going to do 4 lots of that. So the perimeter is equal to 4 times x. So I'll go back to my calculator, do multiply by 4, and 170.71. I can't remember how many decimal places it wanted. 170.71. I'm just checking the answer as we go. And I put it to, didn't round, so I might just double check. Oh, the nearest centimetre. Cool, so 171. And we got the answer right, so that's good. What an exhausting question. That one and the first one, very tricky. All right, now I'm just conscious of the time. We've got 15 minutes before our lesson, so let's just see how we go with question 10. It is possible to find the length of the shorter sides of a right angle isosceles triangle if only the hypotenuse length is known. Okay, so an isosceles triangle, both sides are the same, so this is an x as well. Find the exact value of x in this right-angled isosceles triangle. So we did something similar before. So I'm going to leave you to do that because I think you can do that, similar to what we just did before. Now find the exact value of a in this diagram. So remember, when it says exact value, we're leaving it as a surd. So let's just go and do this question. 2x squared, because we need to use the previous question. 2x squared equals 5 squared. So let's divide both sides by 2. And I'm going to take the square root while we're here. So x is equal to the square root of 25 over 2. Now, if we were doing, okay, so that would be 5 on root 2. Now, if you want to, we can, rationalize the denominator, but I'm just going to leave it like that. So the square root of 25 over the square root of 2 gives you 5 root 2. Now, if we're finding the exact distance of A, we're just adding 6 onto that. So it's going to be 6 plus this distance we found before, so 5 root 2. Okay, and I was just checking that the answer didn't rationalize the denominator. If you're wondering what I'm talking about, when you go into year 10 and you do surds, we don't tend to leave a surd on the denominator, but you don't need to be too concerned about that now. We'll just leave it there. Question C, finally use your result from above to find the length of AB. Okay, so we've got, this will be all right. I can draw this triangle for you. So down the bottom, we've got 6 plus 5 root over root 2. And then remember, this side was 5 over root 2, sorry. And so we're looking for C. So let's substitute them into Pythagoras. So a squared plus b squared equals c squared. So 5 over root 2 squared plus 6 plus 5 over root 2 squared equals c squared. So c is equal to the square root of all this. Now, you can just do this on the calculator. I've just noticed that they've got a little calculator symbol there. You can do this by hand, but it's probably beyond what you're expected to do at year 9. So just put that into your calculator. When I put it into my calculator, I'm going to get a decimal answer. So I'm just going to change my settings so I don't, just so you can see what the answer is. Okay, so square root of, you can hardly see the screen. Sorry, oops, I'm rushing now, I'm making mistakes. Okay, 5 on the square root of 2. And we want, did we need to square that? We do need to square that, don't we? I forgot to put my squared on. Okay. Oh gosh. I don't think that's how it's going to leave the final answer. Let me just write that down. Oh, just to remember it. 30 root 2, 61. Now, is that how it's written the answer? Let me just check. Okay, and oh, it says to correct 1 decimal place. Oh, here I was doing it. Okay. We don't have to leave it in exact form. There we go, 10.17, or to 1 decimal place, 10.2. Sorry, that was my fault. I read it as exact value because we had to do the other ones in exact form. So 10.2, and we're not in any specific unit. So that's the final answer. Good question, that one. All right, these are hard. All right, question 11. Use the method outlined in question 10 for this problem. Oh God, this is going to be fun. In an army navigation exercise, a group of soldiers hiked due south from base camp for 2.5 kilometers to a waterhole. Okay, so north, east, south, west. All right. When I draw diagrams, I always give myself a lot of space to draw it in the middle, especially when you're working with bearings. So we're going south, 2.5 kilometers, so 2.5. From there, they turned 45 degrees to the left. Now that's annoying because I put the 2.5 where I'm going to turn. So I'm just going to rub that out for now. I wonder what way they're facing. So the hike due south to Waterhole. From there, they turned 45 degrees to head southeast. Okay, so they're going this way. So that's 45. And 2.5 here. For 1.6 meters, okay, to a resting point. How far, correct to 1 decimal place, how far east were they from the water hole? So this is their camp, so base camp. This is a water hole, and here's the resting spot. All right, let's add a bit of colour. Okay, so how far east were they from the water hole? So if we draw a right angle triangle here. All right, so here's my triangle. 1.6 is here. Now, because it's a 45 degrees here, that makes this angle also 45. And that makes this one 45 because all your angles inside a triangle have to add up to 180. So when we're labeling our triangle, this side here is X and this side here is X. So now you can, this is why it was saying similar to the previous question, because we're working with an isosceles triangle. So X squared plus X squared equals 1.6 squared. All right, I'm just conscious of the time, so I might leave you to go on to do that. How far south were they? So from the water hole, so that's the same distance, okay, because it's an isosceles triangle. Were they in a straight line from base camp? Were they in a straight line from base camp? I don't understand what that means. How far? Oh, okay. I thought the question was, were they in a straight line? How far were they? So we're looking for this distance here. So what you're going to have is a bigger triangle. All right, so down here is our x. Okay, you work that out. Then our our vertical height is going to be 2.5 plus x. Okay, so that whole distance. And then we've got c. So you need to work out x before you do this part here. So I'll label that A and B. And this is C. And I'm just looking at the time, and I'm going to have enough time to do this question, which is good. Okay, so we've got 2x squared equals 1.6 squared. Let's get x by itself. So x is equal to, let's do it on the calculator. So the square root of 1.6 squared over 2. Oops. Oh, so I've left it in exact mode now, so everything's going to be in exact. So I'll just do Control Enter to put it in. Oh, excuse me. Come on. 1.13. So that's this distance here. So east equals south equals 1.13 kilometers. And the answer says to 1 decimal place, so it should just be 1.1. So I might just rub that out. Okay, and then on our diagram for question C, we've got 1.1 here, and 2.5 plus 1.1 is 3.6. So our working out for that, let's write down Pythagoras' theorem. So it doesn't matter what order you do A and B. So 1.1 squared plus B, 3.6 squared. And when I do this on the calculator, I do prefer not to round. So I'll show you in a sec what I will do. So just take the square root of both sides. So C is equal to, let's go back to our calculator. Okay, so C is equal to the square root of 1.1 squared. So I'm just going to highlight that and square it. Plus, and it was 2.5 plus x. So we did that before, all squared. So you can, all I've done, instead of using 1.1, like I have here, your east-south, your rounded value, I've used the exact, or the more exact answer. Oh gosh. Sorry, I forgot to press approximate. So 3.8 kilometers. And I've just quickly checked the answer and it's correct. And we got them all done with 2 minutes to spare. So girls, that was great. What an effort. Bye.